Hello, McCastle here, and today we're going to be taking a look at one of my favorite add-ons for immersive engineering, and that is control engineering. Now, this used to be called industrial wires. It had a lot more features and stuff when it was part of that, and they pulled out the control panels and a few other things from that, and when they updated it to 1.18 and 1.19, they called it control engineering. Added a few things to it, and that's what we have today. So let's dive in and take a look at this fantastic mod. So we come in here, being an immersive engineering add-on, first thing you always need to point out is the engineer's manual. It's just a lever in a book, and it is your best friend when dealing with immersive engineering, immersive petroleum, control engineering, any of those kind of add-ons. So if you open it up, you see this page, and the nice thing is it automatically adds, when you have add-ons installed, it automatically adds their pages to the bottom of your engineer's manual. So take a look at here if you're lost or you're stuck. I'll try to explain stuff as best as possible, but a lot of times I'm actually going to refer you back to the manual, as it's just such a great tool. So that being said, I also want to point out one of the key features from immersive engineering that is kind of built upon with control engineering. That is the redstone wire, right? So redstone wire is from immersive engineering. Transmits redstone signal without losing its power, right? So if you've got an input of 6 redstone power, the output is 6 redstone power, right? That's essentially the idea there, but it can be transmitted over 16 different color channels, all using the same redstone wire, and that'll be important. So again, 2 aluminum wire, a stick, and a redstone, just like you'd see in immersive engineering. And they've got a couple different interfaces for that. The redstone wire connector, the new redstone interface connector, which is new for logic circuits and things like that are, like I said, new in the newer versions of immersive engineering. Very powerful but simple solution. Control engineering actually builds upon that, and we'll take a look at that a little bit later. And then redstone probe connector, which is essentially a comparator. Or smart comparator, because it's got extra tools or outputs or readings, things that it can grab from different immersive engineering machines. But we're not really going to go into these because, again, they're part of immersive engineering. But we're going to be using these redstone wire connectors here in just a second. Also, part of this whole discussion here is is the engineer screwdriver and the engineer wire cutters. So the screwdriver is important. We're going to use it on some of this other things with immersive control engineering. But even with immersive engineering, you right click on stuff, you can change input or output and what color channel it is running on, right? So this can be output, it's an input, and you just connect your wires by right-clicking one side and right-clicking the other. And if you're too far away or it's going through a block, it'll actually give you an error message. Now, I've got shaders on, so if I turn my shaders off real quick, you'll see that the lines are actually red, so it's easy to sell. And when we look at these in here in a little bit, we'll turn our shaders back off in just a second. So with that, there's 16 kind of patterns, and one of the first things that immersive or control engineering, I'm going to get this mixed up a lot. Control engineering does is has this redstone wire remapper, and it can be connected wherever. But if you hit it with the screwdriver, essentially what it does is it allows you to remap colors of your redstone wire. So if I've got an orange input and I want that to go to, say, a cyan input, I can click here. Other way. Well, you can do it this way too. And I can map it to cyan and vice versa. Now, before this little handy tool, if you wanted to remap stuff because you got a couple different networks or a couple things interacting with each other, you essentially have to put one of the redstone connectors on one side of a block and the other color on as an input on the other side, and it'd power it that way. This allows it to be compact. You can switch back and forth. Essentially, here's the colored side, switching to the gray side, which you can see based on this representation here, right? Colored side coming in, gray side going out. And that's made 2 redstone wire coils, a comparator, some copper wire, and some redstone wire connectors. All right, so the next, one of the main things that is added by control engineering, and a lot of the machines kind of use, is this bus wire, right? So the bus wire is actually 4 redstone wire coils and some aluminum plating. Now, essentially what this does is it allows for 4 different redstone wire signal channels to be passed on. I don't know if that makes sense, but essentially I can pass 4 different red signals, 4 different blue signals, or whatever, right? So, and the channels are 0 through 3, so which is 4 different channels, and we'll show that here in a little bit. So just like with redstone wire, the bus wire has a relay and an interface. A relay is just terracotta, aluminum plates, and redstone dust. This can't connect to any of the machines, but you can connect bus wire to it and then to other areas, just kind of like the connector over here. And then the bus interface, which is some bus wire plates, essentially the same thing, just replace the terracotta with the bus wire. And this does allow you to interface with different machines, and which can take the input and the outputs that way. And then having 4 different redstone buses combined together isn't so useful unless you can get the information out. So these line accesses are actually very important. You'll use these quite a bit when interfacing with anything outside of the machines that come with control engineering. And it basically has a bus input side and a redstone wire input side. And that's kind of seen here by the recipe, right? You have bus wire, bus relay, comparator in the middle, redstone wire, and a redstone wire connector, right? And it creates that. And I just kind of want to show off here how that kind of works. So if I've got a redstone wire connector, I can't connect it to this bus side. I can connect it to the redstone wire side, and vice versa. If I've got this bus interface, I can't connect it to the redstone side, but I can connect it to the bus side. And essentially what that does is this allows us to take out one of the redstone channels that are on here. And the way that you configure that is with the screwdriver. So by right-clicking, it changes which bus line it is pulling out from. So if my signal is coming in on the bus line 1, but my line access is on bus line 0, it's not going to pull that out, which again allows you to pass a lot of information along a single bus line, thus saving memory and all that kind of stuff. That's the other thing I want to show you by turning my it's a white, so you can kind of tell these apart. My shaders unfortunately make them all black, but once you've kind of gone to shaders, it's hard to come back. Just looks so much better. Anyway, not that Minecraft isn't beautiful on its own. Next, let's talk about punch tape. This is another thing that's added in the 1.18 and 1.19 versions. Is punch tape, which is basically a way to carry commands to different machines, as well as a few other things. So let's take a look here. It's just a paint die surrounded by paper, and that gives you a punch tape with 256 characters available. All right, so let's grab some of this. And to use that, you're going to need a keyboard perforator, which is a 5 steel plate, a bus relay, stone button, chain, and iron bars. And now, if you just right-click on this, this is the interface. It's got a keyboard, shift for things here, and then here's where you punch stuff. And as you start typing stuff, it actually sits in there. But you have to first load some empty tape. And this was kind of a frustrating thing for me to figure out. But again, it's in the manual. If you read the manual, you kind of figure this stuff out. But if you notice on here, you can select these different parts up here. And if you click with an empty roll onto here, now it adds that in. And actually, you can keep going. You can add more. So now I have 512. And again, as I start punching, it actually is punching the tape. It's taking away from the characters. And as you can see, you're typing stuff in here. So you say test. See that it's got yellow, lime, light blue, yellow, right? So each character is assigned a color and then actually a redstone power as well. So you can do some pretty complex things with your redstone signals, passing it this way. We'll get into that with the sequencer here, as well as a few other things. Now, this is an unpowered machine. Again, it's just punching tape. And to get the tape out that you punched, you click on this box on the left. And you can actually, right click and view your punched message here. Now you can connect this with the bus connector. This is what the bus connector port looks like. And then you also switch it between loopback and remote transmission, which we'll be taking a look at again here, a couple machines down. But basically loopback is where you're punching the tape, and remote transmission is where another machine is sending information to the perforator to punch the tape. So again, we'll be taking a look at it. You could set these up here. We can show this off. You could set these up here on remote transmission. This one's on loopback. Let's add tape over here. Sorry, I wasn't planning on doing this, but it's okay. Need to show. Put this here. Now, this one is on remote, so if I type over, you gotta connect it with the bus wire. That helps. I'm gonna go in here and I type hello. It types here because I'm in loopback. If it was in remote transmission, it just wouldn't type anything on this side, but it would type over here. But if you notice over here, nothing happened. Maybe this has to be in remote transmission. Sorry. Now if I type hello, you see, there we go. So it's not typing anything over here, but if I come over here, it typed hello. So you could use this as a weird transmission thing, but I wish there was a way for it to type and send. Anyway, it could be a use for it, but there's also some uses here for getting error messages out of machines. But the other thing you can do is you can use these different signals in order to pass that signal along. So, which we're going to take a look at here with the next machine, which is a signal sequencer. So it's 6 treated wood, a circuit backplane, redstone dust, and a bus relay. And this allows you to put perforated tape in the front, but it requires a few different things. It requires power, right? So I've got power coming across from infinite source there. Then it also requires a clock generator. Now there's 3 kinds. There is free running, rising edge, and state triggered. And their different recipes are for the free running, which is basically just a loop. There's redstone torches, redstone in the middle, and 2 aluminum plates. The rising edge is a piston, repeater, dust, and then aluminum plates. And then the state triggered is a redstone free running with some redstone dust. If we take a look in the manual real quick, there's a lot more information in here on this. But if you look here, there's a whole section on clock generators, and it talks about the different ones. And so, see the free running, it triggers 10 equally spaced steps every second. So you just got to space stuff however you want to get that signal out. The state triggered one triggers steps in 100 millisecond intervals while an external signal is applied. So it's essentially the same thing because there's 1,000 milliseconds in a second, so it's 10 every whatever. It's just a different way of saying it. But this one requires a redstone signal to be applied. So if you shut the redstone signal off, it'll stop running. If you have it on, it'll run. And then the rising edge produces a single step each time a redstone signal is. So essentially this is where you can manually sequence it through. So if I hit a redstone signal to it, it'll jump one step down the line. So over here I've got just a free one in here, and it'll just run around. If I was to use the rising edge, I would have to have a button that I could click and it would run through the button every time. And then the state triggered, I would have to have either a lever running on the side or I could attach a redstone wire connector and have a control panel or something else that would feed into that. So this is just kind of showing this off. I've got this tape in here. See, it's got red, 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 lime on lime, green, green, blue, blue, blue. And the reason I did that so that it would go a little bit slower. Otherwise, it speeds through this really quick. So essentially, it's going through these steps a little bit slower because it's going red, 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 lime, 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 green, green. Right, slows it down. So you can do that to kind of change the pace of what you want done on there. Next, we have the panel designer. So this is how we're going to design our control panels, which is one of the main functions of this mod, besides some of the logic stuff you can do with it. And the recipe for the panel designer is a key punch, a piston, glowstone dust, eye of ender, and a couple of treated wood planks. You get this interesting looking thing here. If I pull it out here, you can look all the way around. Well, it doesn't have the bus connector on it. It doesn't have some of the switches. But it does have this button here. And it needs to have... Maybe it doesn't need power. I thought it needed power. I guess it doesn't need power. Alright. Essentially, so what this does is we click on here, and this is where we design our button. So in the old version, you had to have the components ready, basically slap the components on, and they were on there. This one, you design it, it punches the design out onto a punch tape, which you can actually come in here and you could design a panel using the correct syntax for punch for the control panel CNC mill that we'll look at in a minute. You could actually type that up manually if you wanted to, but this basically does it for you, which is, I don't know why you'd try to do it manually, maybe as a challenge. But these are the different components you have. A button. It's actually not like the redstone buttons. It's actually more like a lever. You push it on and you push it off. Timed button is like a redstone button. You click it, and then after time it clicks off. Toggle switch is essentially the same thing as a button. You flip it on, flip it off. The difference is this will glow whichever color you've got it set on for the button, not for the redstone signal. Covered switch just requires 2 clicks. The first click flips it up, second click turns the switch, and then another click just turns it off and puts the cover back on. The Virac, I'm probably saying that way wrong, allows you to essentially turn the wheel, and it changes every click changes the strength of the signal, if I remember correctly. And then a slider is essentially the same thing, just with a slider. You can up the amount that you are sending the signal out. This is a key switch, which we'll take a look at in a minute. Another thing to notice is, I've got 158 characters of the tape available. And if it's red, that means I've used up more. So I either need to add more tape or take some of these components off. The key, though, requires a key to be inserted and then turned for it to switch the switch. So think of it as kind of like the the launch codes. You could set it up where 2 keys had to be put in. I don't know. An indicator is essentially just a light. You'll hook this up to a redstone signal. You can't click it or anything, but it'll light up if that signal is on. Panel meter just reads the signal strength of an incoming redstone signal along the line. And then a label is just the label. Now, these are cool and all, just putting them on here, but you kind of need to be able to edit them. So to do that, you actually right-click. These over here, you select basically the channel, the redstone signal channel that it's on. So orange, lime, right? And then the bus line here is which bus line. So you can pick between any of the 4. So you can have one panel that sends stuff on all 4 bus lines, which is pretty cool there, right? So this is where the buses come in handy. So I could have a bunch of control panels in a row to make this awesome control room, and then I can have it all hooked into one bus line, but be sending, basically 64 different signals out. Bus line 0 white through black, bus line 1 white through black, blah blah blah. Now this RGB, sliders over here actually change the color of the button. So say I wanted a red button, I changed those there. I want it to be red signal, bus line 0. Now my button is red, right? I could do this as I want a white, and so on and so forth. Now the switches, all it allows you to do is change the signal color and the bus line. Same here, except where you can change. Oh, I didn't know that. Learning things new. You can change the color of the cover, it looks like. So I got a blue cover. Here, again, just the signal color. You change the color of the slider on here. Change that. Signal color for the key. The indicator, you can change the light color. The bus line. And in here, you can change the color of the text. So say I wanted like a gray text or gray-green text. I could do that. It's really hard to read. So let's do more like this. Wrong way. And you can look up RGB values if you're looking for a specific color. RGB. And then here you change this as test text. Apparently that didn't go. Alright. Oh, see, for some reason it didn't save any of that. There we go. Anyway, so as you see, as I change stuff, it actually changes the characters required on the punch tape. So what I can do here, I can go in here and I can add some more punch tape to the back of this. And similar to the other one, you add empty tape on here. But the difference is I can click on this and it's not adding anything because I haven't punched the tape yet, right? So I have now 414 available. So when I'm ready to print, come to the side and hit this green button. Now when I hit this, I get my punch tape. And as you can see here, here's the syntax for the stuff, which, I mean, again, you could look that up and read it. It's got it in the manual, if I remember correctly. At the end of the key punch here. Nope. Control panel. Panel designer. Anyway, I'm sure there's somewhere. Here we go. Tape format. Gotcha. So here it gives you all the different examples of how you can do that. So if you wanted to, feel free to do that. Now, once you've designed your panel, you need to take it to the control panel CNC, which is a drill head, iron drill head, 2 steel rods, a sequencer, and 5 planks of treated wood. And it's similar to the sequencer, you plug the design in the front. So I have this design here. Let's pull it out. I believe this is the one we did just now. Yes. Let's put this stuff aside so I don't get confused. Which I do easily. And then what you have to do is you have to make a panel top, a blink one, which is 5 steel plate and a copper wire, which we can grab here. And then the components are not crafted like they used to be. You used to have to craft each individual component, and then you edit it, and then you added it on. But here instead, you basically supply the CNC machine with materials with an adjacent storage container, and it pulls it out of there. And then the only one that's you kind of have to craft separately is the lock and key. Everything else just kind of uses different components. And again, those components are found in the manual. So we come in here, control panels, panel components. Sorry. This goes through each of the different panel components and their required ingredients. Right. Now, I don't know if I have all of this stuff in here. I'm going to keep this out here. So I put this in here. It's going to try to go because I've got power to it. And it's going to start, putting stuff in here. And you see it stopped. Now I've got this bus hooked up here to that's remote transmission. And as you can see here, it printed out this error message for me. But I can't read it on here. I can grab the tape. Unable to consume items. Oop, wrong way. It's a little backwards. For component number 1. So it did component number 0, which is there, but it couldn't do it for number 1. So as long as this got tape, this will actually tell you an error, and you're like, oh crap, I didn't have the right information in there. So let's pull this out. I put a lot of stuff on there. I think this one here was just a pretty basic one. You see it was able to finish it. You come in here, no error code. All right, perfect. So I can pick this panel top up, and we've got a couple more steps to make this complete, right? So to make a control panel, you put the panel top in the middle here, surrounded by steel plates, and that gives you your control panel, which you can place down, and it looks just like that. You can just interact with the different components. Right. The other thing you can do with it, you can take it into an engineer's workbench, and you actually change the angle here. So say I wanted this to be a lot shallower, which I prefer personally. You see it it's a lot shallower. Now you can place these on walls. Sometimes it doesn't render right. I don't know if that's not a shader issue. Might be an angle issue. If you're putting it on the wall, you probably want to change the angle all the way down to 0. And I still can't see him. I think if I remember correctly, it was giving me weird things when it was facing different directions. There you go. See? Which is weird. I'm not sure if that's obviously a bug. I'm not sure how to fix that. But you can also place it on the roof, which doesn't seem as impressive here. But if you, again, increase your height, place it on the roof, it'll be backwards. Let's try that again the other way around. And there you go. Again, not sure what is going on there. It's not showing up on any of these. But you change the angle, so you could, create some pretty complex little control rooms with different heights and different things like that. And then, as long as these control panels are connected, and now it's upside down. You just have to have one bus controller, and it'll connect all of them, I believe. I could be wrong on that one. So last, control panels are a really big piece of this. I absolutely love this, aspect of it. I can create this, super complex control room, which we will be doing in my series once I get into the immersive engineering piece of it. And really, this doesn't just have to control immersive engineering. It has a lot more control over that stuff because there's stuff built into it. But really, anything that runs off a redstone signal, right? Which is the power of it, the beauty of it. But lastly, I wanted to take a look at the logic cabinets and the circuits. So Immersive Engineering added a circuit cabinet, which can do some really simple circuits, but it's quite powerful in that regards that it, can do some logic on top of just redstone, which is it's really cool. Instead of having to build complex redstone circuits, you can do it in a logic. Now, control engineering takes it to the next level, of course, and allows you to create complex circuits and compact it down to just a couple blocks. So, first thing you need to do is to make a logic circuit schematic, which is red dye, green dye, paper, and a bit of this HOP graphite dust, which you need to make the rods and stuff, so it's no use for it. Shoot. I already placed one down. This will be empty, and then you can place a blank one on here. This is a logic workbench, which is slab, storage crate, blueprint, flint and steel, and a light engineering block. And then you put vacuum tubes and copper wires in here, and it'll show you how much is needed for whatever schematic you're making, right? And then you can right-click it with one of these logic circuit backs from Immersive Engineering, which are also what you use in the logic circuits from Immersive Engineering. And basically, it'll create whatever circuit you've got in here, right? So if I add in here, here's all the different, what do they call them? I think they call them like leaflets or whatever. This is all the different operators or things you can do with the inside of the circuit, right? So you can do some pretty complex stuff, as you can see here. I'm not going to explain what all of these do. If you want to look up what they do, again, there's the manual. There's a whole logic cabinet stuff. Talks about the the cabinet themselves, the workbench, how it works, and then these leaf cells is those little pieces that I'm talking about, right? So if you look through here, it talks about how much it costs to put one of these on your schematic, and it basically talks about what they do, right? So tons of things. You can make some extremely complex circuits and different things with these. Very powerful. And really, it's all you do. You can name your schematics. You can say this is a testy. You can add different components. So you say two input and, 3-bit and, ORs, all that good old stuff. Some input pins, some output pins, even just some text if you wanted to label stuff. And yeah, so you can do some really complex stuff. You can do some pretty easy stuff. For example, I could put an AND pin in here. Looking for a digital pin and a digital pin in. So I could come in here and I could add digitized input pin. Say I wanted orange. And I wanted another one that was, so that's how you kind of adjust them, as you grab them. You tell what bus line you want it to work on. Say orange and light blue. And then to draw, you just click where you're starting. Click over and click down. And click Click over, click down. Right, you can draw them, lay them out however you want. And then if I added another one, an output pin, say white, because that makes total sense. Essentially what this would do is if it had a orange signal on 0 bus line and a light blue signal on a 0 bus line, it would output a white line on bus 0. And you can see here I need 3 copper wires, 3 vacuum tubes, and a back. And then again, you just right click it with this. Maybe you do it over here. There we go. Click on the little red thing in the back. And you bring it over to a logic cabinet. Now you just right click it to put it in here. The logic cabinet is a bus relay, a logic unit, which this is the from Immersive Engineering, the vanilla radiator block, and 6 aluminum sheet metal. Now there's a lot going on in here. It requires power, which you do from the back. This little schematic icon here, if you click it, it'll show you your current schematic, which I think is really neat. And then it also requires a clock generator. So if I grab, grab my free running one, came in here. Now this would work, and I just took a bus line up. Actually, I'm going to create a let's create a control panel that this works with. So back over here at our panel designer, let's grab a button. This was orange, and we want orange. Sure, close. Put that on. Yep. Okay. And then we do another button. I want this on light blue. So let's come like that. No. Do like this. Sure, light bluey. And the text button here, we're gonna say this says and then let's just do an indicator here. It's gonna be on the white. And let's just do a white button. Actually, let's do red. Or sorry, I want on the white signal. I want the light to be red. So it'll light up the light when the red and the light blue are met. So here's our punch tape. Bring it over here. Let's pull out this one. Get rid of that garbage. Let's grab one of you. Set it in here. And it should just write our orange button, our light blue button, our and our light. Perfect. Click over here. Get rid of you. Let's change our stuff here. Let's do that to about there. Like how that looks. Our control panel. Bring it over here. We'll hook up our bus. Oh, nope. Our bus relay here, bus relay here. Our line axis here. And then let's do a redstone thing here. And this light here. So this light should light up when we have both blue and red, as well as the indicator on here. So let's hook all this up. Bus to bus, bus to bus, redstone to redstone. Still nothing lit. Let's make sure this is right. Bus line 0. I want this to be output though, right? We've got our free running one in there. We've got our power. All right. So if I come on here and I click blue, nothing, and I click red, oh, our light up there and there. Bada bing, bada boom. So there you go. That's control engineering at its very kind of condensed form. I tried to squeeze in as much as I could here. Hopefully it was informative for you guys. There's a lot you can do here. You can get very complex. You can do some pretty amazing things with it. I'm excited for when we get to this phase in my series. There's a lot that we are going to be hopefully doing with this. We're going to use this to control, our create stuff. We're going to use this to control our immersive engineering stuff, any of that other stuff. So I hope you enjoyed this. If you have any questions, feel free to leave them in the comments below this video. Try to check those, as well as if you have any mods that, like this one, that there's nothing out there video-wise, or the in-game documentation is about all it has. I love to get into new mods. I love to explore things, and I love to kind of help out those that don't have a lot of stuff on it. And if there's any in particular pieces of this you'd like me to go into, like the circuits or the sequencer, any of that kind of stuff, I plan on, I love to experiment with stuff, so maybe I'll post some videos of the different experiments to do. But if you have any questions, I'd love to respond, and if it's easier to do so with the video, I'm always open for that too. So thank you guys for watching, and again, have fun crafting out there. And if you enjoy immersive engineering, this is definitely one for you.